Okay, the infamous solve method. This was a little difficult. So this solve method, I really wanted you to write it exactly the way I had specified in the assignment, where it was public static void solve double A double B double C. And the assignment said that it prints the solution to the quadratic equation. So in your Java docs, I would have expected something like an explanation, something like assumes that solutions are not complex. And maybe before that I would say something like print solutions to 0 is equal to x squared plus bx plus c. And then for parameter a, I would say coefficient of the x squared term doesn't hurt to say, assumes solutions are not complex, uses the quadratic formula. B is the coefficient of x term. C is the constant coefficient. And I was hoping that you would do something like, oh, I don't know, double. Let's calculate the discriminant, and the discriminant is b squared minus 4 times a times c. And then we can calculate a solution 1, and we can say double sol1 is equal to negative b plus the square root of the discriminant all over 2a and solution 2 is just minus the square root of the discriminant. We call this the discriminant. Why? Because the square root of a negative number gives us complex numbers, right? You can't take the square root of a negative number. You end up with this whole I thing. What's this thing complaining about now? Cannot invoke a primitive type double. back to that. Silly me. All over 2a. Forgot the division sign. And it's all over 2 times a. Forgot the multiplication symbol. And I'm being extra careful with these parentheses to control my order of operations. I want to multiply 2 by a before I do the division. Let's see. Okay, so then once we've got our solutions, all we have to do is print them out. System.out.println solution 1 solution 2. So what happens if the equation they give us doesn't have any good solution? Let's try something. So what if we try and call this on, just say solve 1, 2, 3. What happens? Solution 1, NaN. Let's make this a little bit prettier. Solution 1 equals. What does NaN stand for? Not a number. Why? Because the discriminant is b squared minus 4ac. What's b? b is 2. So this is 4. A times c, we've got 2 times 3, that's 6. 6 times 4, well, that's a whole lot bigger than 4, so the discriminant is negative. So we're trying to take this discriminant of a negative number. That's not a number. Not a real number, not something that can be stored in a double anyway, right? So what can we do? If statements to the rescue, conditional statements, right? We can say something like, if the discriminant is less than 0. Do something intelligent. Else do this stuff. Okay, and then we can get something that does not assume that it's got real solutions. So what I would like you to do is find the complex solutions and print them out. So the print statements should come to something like R or A plus I B, where A is the real part of your solution. And B is the imaginary part. Okay, so this is for a complex number. So the idea is that you're going to first compute A, then compute B. then print something like A plus, and inside of quotes, a plus I plus B, where A and B are variables that are both declared as doubles. How do you get A and how do you get B? Well, you may want to talk to a math teacher, but I'm thinking that A might be something like negative B over 2A. Let's call it RE and IM. And how do you get the imaginary part? Well, you're going to have a positive imaginary part, and you're going to have a negative imaginary part. That gives you your two solutions. And it's going to be something like the square root of the discriminant over 2a, or something to that effect. So the idea is that here we're trying to create a more robust solve method by using conditional statements. Shouldn't be too hard of an assignment. You'll have to think just a little. Give it a try. If you have any questions, problems, please let me know. Thanks.